The paint on your car, the insulation keeping your house warm, the fertilizers securing the food in your grocery store. You interact with highly engineered chemical products hundreds of times a day without ever noticing them. Most of these invisible layers trace back to a single source, a German corporation called BASF, which stands as the absolute largest chemical producer on Earth by revenue. To maintain that kind of output requires a staggering human infrastructure. Today, BASF employs roughly 112,000 people across the globe, operating massive industrial complexes that run around the clock. And yet, despite manufacturing the literal physical building blocks of modern civilization, they sell almost nothing directly to you. They are the ultimate hidden architects of our physical world. This photograph shows a sprawling, smoke-stacked chemical plant, typical of the heavy industrial machinery required for mass manufacturing. To understand how a facility like this comes to be, we have to look back to the German Industrial Revolution in the 1800s, an era powered almost entirely by burning raw coal. Processing all that coal left behind mountains of a thick, toxic byproduct known as coal tar. But a chemist named Friedrich Engelhorn looked at that sludge and saw an entirely different set of molecules. Engelhorn figured out how to extract vibrant, highly sought-after dyes and pigments straight from that waste. He built a factory to scale the process, naming it the Badische Aniline und Soda Fabrik. That early chemistry proved you could synthesize immense value from industrial garbage, but it also required a heavy, carbon-intensive manufacturing process, setting the foundation for a global giant that would leave a massive environmental footprint on the planet. Between the 1920s and the 1950s, BASF rapidly outgrew simple dyes. They scaled up their operations to master bulk chemical production, most notably synthesizing thousands of tons of ammonia to feed a growing global population. Then came the decades that truly built the modern physical world. From the 1950s through the 1970s, chemistry evolved. Scientists stopped merely extracting things from nature. They began engineering entirely new materials from scratch. You can see that transition happening here, with lab workers physically inspecting newly synthesized plastic components. This era saw BASF invent new plastics and superabsorbent polymers that quickly replaced traditional materials like wood and metal in global manufacturing. They engineered specific molecular compounds, known as MDI and TDI. These are the critical chemical building blocks used to create polyurethane foams. If you look inside the walls of nearly any modern construction project, you'll find these foams insulating the building. Take a look at this vintage Alfa Romeo assembly line. BASF expanded heavily into advanced surface technologies, formulating the exact chemical coatings that mass production automakers required to protect and finish their vehicles. Today, heavyweights like Mercedes-Benz and BMW still rely on these precise chemical formulations. Over a 50-year sprint, they wove themselves into the fabric of human industry. By supplying the plastics, foams, and coatings, BASF became the indispensable physical foundation for almost every manufacturing sector on Earth. Entering the 2000s, BASF pushed even further. This map visualizes their aggressive expansion into emerging markets across China, India, and the Middle East. They began acquiring specialized companies in agricultural solutions, crop protection, and nutrition to lock down those growing sectors. By absorbing all these different industries, they built a hyper-complex, interconnected web. Thousands of raw petrochemical inputs now flow through this system, chemically transforming into the final materials that feed our agricultural and consumer markets. But there is a massive structural flaw built into the base of this network. The entire system is violently energy-intensive, completely dependent on extracting and processing heavy petrochemicals, oil, and gas. This presents a severe existential threat. BASF is a massive carbon-emitting machine operating in a world that has officially mandated rapid global decarbonization. The unmatched global scale they spent a century building is now their absolute greatest liability. To survive the coming decades, they have to figure out how to chemically re-engineer their entire infrastructure from the ground up, or face complete obsolescence. To stay alive, BASF has committed to an incredibly aggressive target, achieving absolute net zero emissions by 2050. That means they have roughly 25 years to execute a complete operational reversal of a century-old industrial model. You can't reach that number by just planting some trees to offset carbon. Their strategy demands a full transition to Industry 4.0, digitizing every single aspect of their heavy chemical manufacturing. Notice the precision of this automated robotic arm. BASF is heavily deploying smart factories and AI-driven robotics precisely like this. The goal is to mathematically optimize their production lines down to the millisecond, entirely stripping out the inefficiencies and waste of manual heavy industry. They are also forcibly weaning their facilities off fossil fuels. That means pouring massive capital into plant electrification and developing a green hydrogen economy to generate the immense heat required for chemical synthesis without producing CO2. And look at what those automated factories are actually producing now. This conveyor line handles advanced battery modules. BASF is actively shifting their core product catalog toward next-generation battery materials to physically power the global transition to electric vehicles. For a company of this size, decarbonization is no longer a PR initiative or a regulatory checkbox. It is the core engineering engine required to keep the business alive. Beyond the factories, they are trying to close the loop completely by building a circular economy. The goal is to ensure that when a chemical product reaches the end of its useful life, it isn't thrown in a landfill, but fed directly back into the start of a new. In a way, this modern pursuit perfectly mirrors the original problem Friedrich Engelhorn faced in the 1800s. It is the exact same corporate ethos of looking at highly toxic waste, whether it's coal tar or end-of-life plastics, and chemically extracting immense value from it. The ultimate test for BASF lies right there. The exact same relentless physical engineering that built our carbon-heavy modern reality must now be used to save it.